نبدأ الجلسة.
بسم الله الرحمن الرحيم. تفضل يا فندم.
طبعا أكيد في معانا أجانب أعتقد، فممكن on behalf of the ICEST2021 we welcome all the authors. Today session, technical session number 7. We will start with paper number. معلش دكتور أيمن، حضرتك البيبر رقم كام بالظبط؟
أنا اللي هي سادس واحدة اللي هي 2271.
تمام. With the ICEST 2171 throughput improvement for Internet of Things networks with scalability and security consideration. Authors Dr. Ayman Hajjaj from Helwan University.
شكرا جزيلا يا فندم. استاذن حضرتك واعمل شير.
اتفضل سيدي.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله جميعا. أتشرف دكتور هاني، شكرا جزيلا لحضرتك وشكرا على تقديم البحث بتاعي، وأستاذن حضراتكم في إلقائه يعني بعد إذن حضراتكم، يعني سابق عن موعده لظروف خاصة، يعني جزاكم الله كل خير. دكتور هاني، تحب أتكلم إنجليزي ولا عربي؟
والله هو حضرتك لو في اجانب هيفضل انجليش يعني، بس انا اشوف بس المشاركين. هو في حضرتك اتنين يعني.
طيب انا انجليزي ان شاء الله، انجليزي
يعني يفضل لو كده.
لا ده ناتشرال. I would like to start introducing my research. My article title is Throughput Improvement for Internet of Things Networks with Scalability and Security Considerations. My name is Dr. Ayman Hajjaj. I am from Helwan University, Egypt. Our agenda today, IoT imposes a scalability demand for networked devices. I will talk about the architectural requirements of IoT. And then I propose using the IP version 6 addressing for the IoT. I will propose the use of IP version 6 with adaptation, because IP version 6 can support large number of devices, and this is a very important demand for Internet of Things. However, the payload of using IP version 6 is very big, and devices used with IoT are limited in resources. So I will propose some adaptations to IP version 6 in order to allow for improved performance of Internet of Things. I will also propose an objective function for IoT routing protocols. Then I will show my simulation and results, and then I will conclude with my conclusion and future work. This is the abstract of the article I have submitted to the conference. Internet of Things IoT scale is several hundreds of magnitude bigger than enterprise networks. So the scale is like 100 times. So if I have an enterprise with like 100 computers and 100 nodes, with Internet of Things, I'm talking about the scale of 10,000 devices per company or per site, because it includes using sensors and using smart devices. So the scale is very large. The requirements needed for IoT are scalability. So I'm dealing with a very large number of devices. Low power consumption. These devices are limited in their power supply. Some of them are battery power supplied. So I have to preserve the battery. And simplified routing. So the routing protocol should be simple because those devices don't have a lot of processing. And also, of course, security protocols must be increased because Internet of Things is not only about information, is about devices. So and also about functionality. So if some security attack happen on, for example, the smart grid or the transportation system, I think this will have severe economic effect. The protocols used with the internet like OSPF and BGP, those standard protocol have deemed to be inefficient or insufficient for IoT. In this research, we apply IP version 6 to IoT networks to avoid the scalability bottleneck of IP version 6 subnet and for accommodation for large number of connected devices and to solve the heterogeneous nature and access method of IoT devices. Also, we apply adaptation to IP version 6 through header compression for throughput improvement. We also propose a modified routing protocol with a new objective function for energy limited devices with better supply, with battery supply. So as we see, the number of smart devices, let's look at, like, for example, in 2003, at that time there were no smart devices at all. To 2003, we could only hardly have a computer. By that time, we have the mobile phone was not smart, was just a mobile phone. And then we see over time, the number, of course, the number of population is increasing. However, the number of smart devices is much more rapidly increasing. And then, like 2015, we started to have the definition of Internet of Things, and things like smart devices are becoming part of the network. So by 2020, we have about 20 billion smart devices. And for example, every person, like as you see in the diagram here, every person owns about 6 or 7 devices. Not 6 or 7 mobile phones, but for example, at home, the surveillance camera becomes a device. The television becomes a device, and all these devices, they are connected to what we are calling now the Internet of Things. So the scalability demand for networked device is aiming very, very high. So IoT has a lot of requirements. I have summarized some of these requirements. IoT is made up of many constrained devices. By constrained, I mean they are limited in their power. They are limited in their resources. They are limited in the processing power. For example, smart meters, actuator, relays, sensors, etc. All these are smart devices that are limited, and I call them constrained device. Constrained IoT networks have unique requirements. Sensors typically run on low power, battery, and are lossy. So messages are not sent 100% successfully over the time. So I'm dealing with a lossy network with lots of errors and packet loss. Constrained restricted frame size. Restricted frame size. Thus, routing protocol for lossy network should be specially adapted for such link layers. Also, scalability is massive, requiring more scalable routing protocol. Some IoT applications are time sensitive. For example, like nowadays, we are talking about autonomous vehicles. And autonomous vehicles, computers are controlling the position of the car in the street in real time. So if information is to be arrived with a delay, I think this may result in some sort of accidents or life-threatening or loss of properties. So also deterministic response time. Also, devices are in the public. So, for example, if I have a smart meter and an attacker managed to plug into that smart meter and becomes part of the network, I think he can impose a lot of security threats. So these are the requirements for the IoT architecture. Also, another nature of IoT is that it is heterogeneous, which means I have different types of devices and also so many different types of communication protocols. So I have mentioned, for example, a network would be created using Bluetooth, using Wi-Fi, using 3GPP, RFID. I have mentioned some of the protocols used as communication between IoT devices, and those devices refer to those above mentioned standards. So in my opinion, IP version 6 offers a common network layer for end-to-end communication. Also, I tried to put a model for the Internet of Things. So I am applying a 7-layer model. So for example, at the lower layer, at layer 1, I have physical devices. Those physical devices are things like, for example, smart meters, energy nodes, intelligent nodes. Okay, at the layer number 2, I have connectivity. And as I have mentioned, connectivity device, for example, connectivity using Bluetooth, or connectivity using Wi-Fi or RFID. So I have different types of connectivity methods at layer 2. And then at layer 3, I have fog computing. So with Internet of Things, we are collecting information to a central point. And that point, for example, would be a cloud server where data starts to be analyzed, to take decisions, or for example, to start to collect meter readings from a smart grid, or to control a smart grid for a smart city. And then we get for the data accumulation and then storage, data abstraction. So I'm trying to extract important information out of this data. And then in the upper layer, I have the application running at the top layer, and then collaboration and processes. So this is the reference model for Internet of Things. And then I started to notice that some of the, because I'm proposing the use of IP version 6 for the lower layers of the IoT stack, but upper layers in the IoT stack, they are now being run and using IP version 4, which is the common protocol used for typical internet. So I have a kind of interface or a split at that layer. So I need adaptation. I need a sort of adaptation layer between IP version 4 and IP version 6. So I need to consider integration of Internet of Things with legacy network, old traditional networks. Here I am presenting a comparison between IP version 4 and IP version 6. IP version 4 is 32-bit address length. However, IP version 6 is 128-bit address length. And this result, because of it is IP version 4 only has about 4 billion devices, 4 billion address space. However, IP version 6 can extend to something like 3.4 multiplied by 10 to the power of 38 device. This is extremely huge number of devices that may be connected together, and this is necessary for Internet of Things. Also, IP version 4 is end-to-end connection integrity is unachievable, cannot guarantee end-to-end connectivity. However, IP version 6 can guarantee this. The security feature of IP version 4 depend on the application. In IP version 6, I have a security protocol called IPsec, which is an inbuilt security feature in IP version 6 protocol. IP version 4 encryption and authentication not provided. They are provided in IP version 6. However, I have a problem. So all the comparison between IP version 4 and IP version 6 are in favor in IP version 6. However, the size, the packet size, and the header size of IP version 6 is larger, which is a problem with constrained devices. So as you see, I need to use IP version 6 with adaptation. With adaptation, I need to reduce the length of the packet in IP version 6 to support being transmitted through limited devices, and also to support the performance when I have a lossy network. So I am proposing an adaptation layer between the TCP protocol and the wireless protocol used for Internet of Things. So in this diagram, I am illustrating my compression method. So the IEEE 0 to 1.54 frame length is constrained to be 127 bytes to support limited devices and to support lossy transmission. So originally, IP version 6 header would take 40 bytes, leaving very little room for other information like the payload, the data being transmitted. So in my proposal, I'm applying compression, and I'm also applying compression in a compatible way so that I can have more space for the payload. So user datagram protocol is a communication protocol that is primarily used to establish low latency, loss tolerating connection between applications on the internet. UDP speeds up transmission by enabling the transfer of data before an agreement is provided by the receiving party. So UDP transmission protocol is utilized for Internet of Things. Header compression is a trade-off between getting a small packet header, which pays off in less receiver transmission time, and traditional computing resources needed for compressing. Because if I apply compression, I need the device to be able to compress and uncompress information, which requires additional processing. So I will summarize in brief. So the proposed payload, I compress the IP for improved performance, and then I will talk about two aspects of my presentation. That is mesh IoT. This is the picture of a typical IoT network where devices are forwarding data in a rather mesh way. So the protocol. So I will just show two slides because of limited time. I will show two slides and for a proposed improvement in my protocol. This device is battery powered. So if information is going through this device, I think the battery drain will be faster. So I propose a modification to the routing protocol in order to avoid the consumption of power limited devices by considering the power. So for example, routing would be routed like this. And after considering that this device is limited in power, I can change by considering the energy consumption. I can consider changing routing path to avoid draining the battery. So I simulated my proposed technique, and then after considering avoiding using the that is powered by battery, I was able to preserve about 45% of the charge of that battery and increase its battery life. So in conclusion, traditional protocols are not well suited for large-scale heterogeneous constrained IoT network. In this research, IP version 6 and UDP were utilized for IoT networks with a proposed adaptation of header and payload compression. Modified routing protocols were also proposed for large-scale mesh IoT networks that consider node energy as an additional objective function in node ranking. The proposed technique decreases approximately 45% the average power consumption of that device. My future work is extend the IP version 6 adaptation for IoT requirement, improve objective functions for enhancing IoT routing protocol, and also apply security to IoT networks. I'm very thankful for your time and for your attention. I hope I was able to clarify my ideas, and I would love to listen to hear your comments. So you may contact me at my email address, and I am back to the organizing committee. And thank you very much for the additional time I have taken. Thank you very much, Dr. Ali.
Thank you so much, Professor Dr. Ayman, for the interesting presentation. Now we open the discussion. Is there any questions for?
I will stop sharing, and please, so that you may.
Yeah, thank you so much, Professor Ayman, for the presentation. I think there is no questions. So we move forward to the next presentation. So thank you so much, Professor Dr. Ayman. Thank you so much. The next one is ICEST2022 Transmission Performance with Nonlinear Distortions Investigation in Multiband OFDM ROF-based DWDM System.
السلام عليكم أساتذتنا الأعزاء، إن شاء الله تكونون بخير وسلامة.
أهلا بحضرتك.
الله يحفظك ويسلمك. أستاذ أنا أستاذ مصدق ماهر عبد الزهرة، أستاذ في كلية المستقبل الجامعة اللي هي موجودة في العراق في بالحلة تحديدا. أدرس حاليا الاتصالات وبالتحديد الاتصالات الضوئية في دراستي للدكتوراه، بالإضافة إلى أنه حضراتكم اشتركت بمجموعة من إذا شفتوا أنتم أنه أكثر من بحث اشتركنا اللي هي عبارة عن مشاريع للطلبة، بالإضافة إلى أنه هي عبارة عن بحوث علمية في مجال الاتصالات الضوئية تتناول تقنيات حديثة جدا وإلها تأثير في زيادة طاقة الاتصالات الضوئية وعملية نقل البيانات مثل ما راح تشوفون حضراتكم إن شاء الله. طبعا الصراحة احنا اشتركنا بأكثر من بحث، راح أني أعرض واحد من البحوث بطريقة الباوربوينت ونعرض أهم النتائج اللي حصلنا عليها. راح نكون أيضا راح أتناول مجموعة البحوث الأخرى بطريقة مختصرة على غرار حتى نختصر بالوقت، ومثل ما اتفقنا مع الدكتور حتى ما ناخذ من وقتكم هواية. فبعد إذنكم راح أسوي شير للباوربوينت الخاص.
Yes, you can share now. You have around 10 minutes to 15 minutes for the presentation. Yeah, thank you.
Okay, thank you, Doctor. السلام عليكم. في البداية مثل ما طرقنا أنه احنا عندنا مجموعة بحثية تتعلق في نظام الاتصالات المتنقلة وتحديدا الاتصالات الضوئية. في البداية عندنا 4 مشاريع، كل واحد من هالمشاريع يتناول أهم التقنيات اللي موجودة حاليا. قمنا بعمل simulation frameworks اللي هي عبارة عن أنظمة محاكاة حديثة باستخدام نظام متطور اللي هو نظام Fpga Photonics، اللي هو يعتبر من أكثر الأنظمة المتطورة في نظام تصميم الاتصالات المتنقلة وتحديدا الاتصالات الضوئية. أول هذه البحوث هو Impact of Non-Linear Distortion in Radio over Fiber Systems، واللي احنا خصصناه باستخدام مجموعة من الشانلات اللي هي خاصة بالأورثوغونال Frequency Division Multiplexing OFDM Systems. راح نتناول introduction theory مع radio over fiber، البروبلمز والسولوشنز، بالإضافة النوفل ديزاين مع radio over fiber systems، بالإضافة إلى system results، وأيضا راح نفتح باب المناقشة بالنسبة لهذا الموضوع. طبعا مع زيادة تطور العلم والتكنولوجيا بالوقت الحاضر، وبعد ما أنه شفنا أنه عندنا ترافيك increased internationally بدول العالم، بالإضافة إلى أنه عندنا بالنسبة لللوكال areas كتغطية وكاحتياج للأشخاص للاتصالات ولنقل البيانات بشكل عام ازداد بشكل كبير خلال هاي السنين الماضية. الأوبتيكال نتوركس اللي هي الاتصالات الضوئية والاتصالات شبكات الاتصالات تستخدم الأوبتيكال فايبر، سواء كان السنجل مود فايبر أو المولتي مود فايبر، في عملية تصميم أنظمة الاتصالات ونقل البيانات. هنالك العديد من التقنيات تم استخدامها في الوقت الحاضر. من أهم هاي التقنيات هو الراديو أوفر فايبر سيستم. مثل ما نعرف أنه الراديو أوفر فايبر سيستم هو عبارة عن نظام قديم من ناحية اكتشافه، لكن لحد الآن ولحد تقنية ال 5G والبيوند 5G يستخدمون راديو أوفر فايبر، وذلك لكفاءته في عملية نقل البيانات. الراديو أوفر فايبر هو عبارة عن نظام يقوم بعملية نقل البيانات اللاسلكية عن طريق الاتصالات الضوئية أو عن طريق الأوبتيكال فايبر اللي هو الضوء اللي موجود. وهنالك العديد من التقنيات يتم استخدامها لتحديث هذا النظام. عندنا 3 مشاكل رئيسية، طبعا تم اختصار مجموعة من السلايدات قلنا حتى نختصر بالهذا. عندنا المشاكل الرئيسية اللي نعاني منها الشبكات الحالية هي الكاباسيتي كرانش، الكوست، واللو بيرفورمانس. الكاباسيتي كرانش هي مثل ما نعرف انه مهما كان معدل نقل البيانات راح نحتاج دائما الى بيانات اعلى حتى نقوم ب معالجة ضعف البيانات الحالية. صح عندنا نقل بيانات عالي جدا بالأنظمة مثل 5G، لكن هنالك عديد من المشاكل بناحية نقل البيانات وسرعتها. بالإضافة أنه الكوست العالي اللي هي التكلفة العالية في ناحية تصميم النظام بأكمله. اللو بيرفورمانس راح نتعرض لها من ناحية النويز والديستورشنز، بالإضافة إلى الخسائر الأخرى اللي راح تواجهنا بالنظام. علاج هذا الموضوع وحتى احنا نقوم ملمين بجميع الامور ونعالج الخسائر والاضافه للكاباسيتي كرانش، تم تصميم النظام اللي هو عباره عن سوبر شانل ترانسميشن. تم تصميمه اللي هو يتكون من اوبتيكال او اف دي ام اللي هو عمليه نقل ترانسفورميشن للاو اف دي ام الاورثوغونال فريكونسي ديفيجن مالتيبلكسنج سيستم عن طريق الالترا باندويث بين 2 تاورز. هنا راح يتيح لنا هذا 4 امور مهمه جدا اللي هي اللونج هول ترانسميشن، الترا هاي كاباسيتي نتورك، والكوست كونسيومشن، بالاضافه الى الليس سسبتيف لوسز. جنرال proposed radio over fiber system هو عباره عن 3 اجزاء رئيسيه، هن الترانسميشن سكشن، الشانل، والريسيفر. قمنا بتصميم ال3 اجزاء حتى نحصل على النظام الخاص بنا. الترانسميشن سيستم يحتوي على الداتا ان او اف دي ام سيستم مثل ما راح نشوفها بالسيستم باكمله، اضافه الى انه الشانل مالتنا راح تحتوي لي على الراديو اوفر فايبر ويا الاو اف دي ام سيستم، عمليه نقلها عن طريق الشانل، بالاضافه الى انه راح تتوجه الى الريسيفر. نستخدم دي اس بي اللي هي ديجيتال سيجنال بروسيسنج حديثه حتى نقوم باستلام البيانات والاستفاده من عندها. من هذا الموضوع تم تصميم النظام مالتنا اللي هو Design and Implementation of Radio over Fiber System، وندرس أيضا الإمباكت of Non-Linear Distortion. من أهم المشاكل الموجودة بالأنظمة الحالية فيما يتعلق بالراديو over Fiber System هي Non-Linear Distortions اللي هي عبارة عن خسائر اللا خطية. هذا النظام اللي خاص بنا عبارة عن تصميم لنظام يحتوي على 5 شانلات، 5 قنوات لاو اف دي ام سيستم. طبعا احنا مختصريها لانه بصراحه السيستم ان شاء الله تشوفوه بالبحث عباره عن تصميم كامل لاو اف دي ام شانل، تعشيق الداتا وبعدين تحويلها الى او اف دي ام سيستم، وبعدها عمليه دمجهن وارسالهن عن طريق ليزر درايفر. بعدين عندنا ريت ايكويشن اللي هو يقوم بعمليه حسابات خاصه ونقلها عن طريق الاوبتيكال فايبر، استخدمنا سنجل مود فايبر. وبالريسيفر راح يكون عندي ايضا هنا فوتو ديتكتور حتى يكشف لي الضوء اللي يحتوي على الداتا الخاصه بالاو اف دي ام سيستمز. هنا عندنا مجموعه من الميجرمنتس اللي هي خاصه بالايرور فيكتور ماجنتيودز، وتقوم بعمليه قياس الثيرد اوردر اي ام دي اللي هو انترميديت ديستورشن اللي هو يعتبر خسائر لا خطيه، بالاضافه الى مجموعه من الخسائر ايضا ان شاء الله راح نقوم بعمليه دراستها. بعدها عندنا مجموعه من الانالايزرز اللي هي مجموعه من عارضات النتائج اللي راح تعرضنا النتائج الخاصه بنا. طبعا الفي بي اي ساعدنا جدا في عمليه الحصول على البيانات، وهذا الموضوع كان كلش اتراكتيف بالنسبه لنا، انه اني بالنسبه لي انه اخلي طلاب يتعاملون مع هكذا برنامج وبهذه الفئه العمريه وبهالعمر. طبعا ان شاء الله نعتبره انجاز بالنسبه لنا، ونطلع ببحوث ممكن انه تفيدنا بالمستقبل ان شاء الله. طبعا عندنا مجموعه من النتائج من ضمنها الكونستليشن دايجرامز، استخدمنا 16 كيو اي ام موديليشن فورمات بالارسال. مثل ما تعرفون انتم دائما الاو اف دي ام يعطيني خيار انه يكون سب كارير بداخله اللي هو الموديليشن فورمات السب كارير، ايضا راح اقوم بعمليه تضمينه. فتم الحصول على مجموعه، هنا اخذنا عينات اللي هي مجموعه من الكونستليشن دايجرامز بالنسبه لمجموعه من القنوات تم وصولها عن طريق الريسيفر. طبعا عندنا الكتريكال سبيكترم، مثل ما تعرفون الاو اف دي ام هو عباره عن من اول وتالي اطلع الالكتريكال سبيكترم وعمليه ارساله مثل ما تشوفون، هذا كان الشكل بالنسبه له. بالاضافه الى مثل ما تشوفون عندنا مجموعه من النتائج، عندنا الفايبر لينث بير موديليشن امبليتيود، الفريكونسي بير باور، بالاضافه الى انه حصلنا على الكونستليشن اللي موجود. وهنا قمنا بعمليه هذا حساب للايرور فيكتور ماجنتيود مع الانترميديت فريكونسي ديستورشن اللي هو يعتبر من اهم الخسائر اللا خطيه. طبعا الصراحه قمنا بحذف مجموعه من السلايدات، هنالك امور اخرى ان شاء الله احنا اكملنا، لكن راح اعطي فقط نبذه بالنسبه للمشاريع الاخرى، واذا تردون نعرضها ايضا موجودات. لكن اللي صار هو انه بدل ما استخدم اني راديو اوفر فايبر، استخدم مثلا اس دي ام سيستم اللي هو سبيس ديفيجن مالتيبلكسنج سيستم. هذا النظام يتيح لي انه اني اقوم بعمليه نقل بيانات ان مالتي كور فايبرز اللي هي عباره عن مجموعه من الاضويه، اقوم بعمليه مود كابلنج بيناتهم وارسلهن عن طريق الترانسميشن سيستم عن طريق ضوء لمسافات بعيده. هذا ايضا حقق لنا بحث اخر بانجازات، وايضا تم ارسال البيانات وحصلنا على معدل نقل بيانات وصل الى 5 إلى 6 تيرا بت بير سكند، وايضا يعتبر من الانظمه عاليه الحصول على بيانات عاليه وبسرعه عاليه جدا، والمسافات ايضا بعيده. ايضا تم استخدام الاو اف دي ام سيستم للارسال لمسافات وصلت الى 1000 كيلومتر بالنسبه لنظام الارسال. ايضا هذا اعطانا كونتريبيوشن ثالث. بالاضافه الى هذا استخدمنا المايمو سيستم. المايمو سيستم نعرف لحد الان يتم استخدامه بالانظمه، استخدمناه بعمليه نقل لمجموعه من البيانات. ايضا حصلنا على معدل نقل بيانات عالي جدا. المايمو سيستم يتيح لي انه مالتي انبوت مالتي اوتبوت، يعطيني يكثر لي يعلي لي البرفورمانس بالنسبه للنظام. بالاضافه الى ممكن استخدامه بالريسيفر كدي اس بي حتى يعالج لي بيانات. أنا آسف جدا أخرتكم وأطلت الكلام، لكن لأنه وقت محدود فما أقدر أنه بعد نتجاوز على وقت المؤتمر. أي سؤال أي شيء أنا حاضر وجاهز لأي استفسار. شكرا جزيلا لكم دكتور.
Thank you so much, Professor Dr. Musaddiq from Mustaqbal University College, Iraq.
شكرا لكم دكتور.
Now, so we can open discussion for the presentation. Is there are any questions? So thank you so much, Professor Musaddiq.
Thank you دكتور. ان شاء الله نكون وياكم وان شاء الله السنوات القادمه ايضا. شكرا لكم وتعبناكم ويانا. شكرا جزيلا لكم.
شرفنا بك. شرفنا بحضرتك وشكرا على البرزنتيشن.
الله يحفظك دكتور. اهلا وسهلا بك. الله يخليك.
دكتور ايمن
مع حضرتك يا دكتور. حضرتك اللي بعده هيبقى بقى Fpga.
تمام حضرتك.
طيب شكرا جزيلا لحضرتك. تحياتي لحضراتكم جميعا. ان شاء الله البحث التالي Fpga based industrial robotic arm controller from Dr. Mujta Muhammad Irshad from India. Please proceed. Please kindly Dr. Mustaqbal kindly stop sharing. Dr. Musaddaq, please stop sharing. دكتور مصدق لو سمحت حضرتك اوقف.
تمام دكتور، تمام ان شاء الله.
شكرا لحضرتك، شكرا. لا تخرج يعني. ايوه تمام.
لا دكتور،
جزيلا لحضرتك.
دكتور باقي معاكم، لكن انا مشير من غير مكان. شكرا جزيلا وياكم.
حضرتك تخرج. لا
الله يحفظك.
طيب حضرتك الاوثرز for the next article please start sharing. Authors from Fpga. Okay.
Hello.
Thank you very much. Please proceed.
Good evening, everyone. Thanks for allowing me to present my paper. And my project name is Fpga based industrial roboticum, which is we have designed a roboticum controller using VHDL. Using VHDL named Labview Fpga. The introduction of Roboticum. The basic objective of this project, the name itself it suggests it's a Roboticum. So the basic objective is just to control servo motors using Fpga as a processor. So as we have seen many Roboticums where the control is from hardware like potentiometer or some joystick. So we have decided to make a interface called graphical user interface to interact with user, and he can so it will be flexible to the user to control the Roboticum. So in this project we have used a controller NICEST, which is a product of National Instruments, and the language used is Labview, Labview Fpga. So it is a HDL language where in market we can have frequently we use Verilog or VHDL, but these are the top of the.
ஆனா மேல செஷன் வந்து 5 ஒன்னு வச்சிருக்காங்க. அதுல ஆமா அதுதான்
top languages of
பாத்தீங்கன்னா டாப்ல பாருங்க செஷன் 5 வச்சிருக்காங்க உள்ள.
Okay, why we have choose Labview Fpga? Because we are designing a prototype for industrial roboticum. So by choosing Labview Fpga, it allows us to code very fast, and it allows us to do prototyping very fast rather than Verilog or VHDL. So this is the Roboticum we have designed. So actually the Roboticum is a 6-axis mechanism, so it can it has a full flexibility to its movement, and we have used 3 actuators in this. The actuator is servo motor, so one servo motor we have kept for shoulder movements, and one for elbow movements, and one for the end effector. So end effector is to pick up the objects and place the objects. So specification of this Roboticum is our Roboticum has 6 axes, and as it has 6 axes, so the degree of freedom is 6, and we have used 4 servo motors. Actually here I forgot, and we actually have set 3 servo motors: shoulder, elbow, and end effector, and another servo motor is the base to rotate the whole body of the Roboticum. It's below the body. So as I have said, the robotic arm is 6 axis. So we have provided at every joint we have given flexibility up to 180 degrees, so that if in industrial places, if we can change it, if we change the place of workspace, it can be adjusted to that environment. So these are the specifications of Roboticum, and this is the block diagram. So what block diagram is showing is, first, as I have said, for graphical user interface, also we have choose the Labview. So from Labview, the front panel provides us a graphical user interface to the user to control the Roboticum. So whenever the user controls the Roboticum from front panel, and the user, the data goes to the NS Stereo, which is the controller we are using. The Stereo process the data received from user and makes it into it generates the PWM signal according to the angle which the user selected, and the PWM signal are given to the servo motor. And after servo motor receives the PWM signal, the movement of Roboticum starts, just like the user desires to. And this is the GUI of our Roboticum. So here we can see we have chose 4 indicators here: time period 1, 2, 3, 4. These are used to define the time period of the PWM signal. So here we have used 20 milliseconds as we have used servo motor as an actuator. It takes PWM frequency of 50 hertz. So we have to take a time period of 20 milliseconds to generate PWM signal. And there are 4 controllers we are providing. The bottom one is for base to control the whole body between base to, and 2 vertical sliders are for shoulder and elbow to make x-axis movement, and to make y-axis movement. And the top one is end effector controller to use when the robotic arm reaches to the object. Through this we can either hold the object, or either release the object. So these are the some movements of our Roboticum, and the figure 4 shows the movement of end effector. So here what it is doing is closing and just closing and opening the end effector. And the figure 5 shows the movement of shoulders, which is y-axis, and it makes the object up and down. So the conclusion is we have discussed about 6 degree of freedom robotic arm controller, which is designed using Fpga Labview environment. So where it is more efficient than other controllers. The result, we have successfully designed a 6-axis industrial pick and place robot to perform various operations in industry, and at the same time we have provided a graphical user interface to provide full flexible control to the user. And this is our project video where the Roboticum does pick and place of object. As the Roboticum is controlled by the user interface, and it releases the object at the goal. And this is the this is whole, like as I have told, we have designed a 6-axis robot. So this is just all the movements of the robot that the Roboticum can perform. This is the movement of base from 0 to 180. And this is of elbow from y-axis. And this is the x-axis movement. This is movement of end effector. Thank you for allowing me to present this paper. Any queries to ask?
Thank you very much for this interesting presentation.
Thank you.
I would like to ask, are there any questions? Are there any questions? Okay, so thank you. And we are back to you, Dr. Hani. Please proceed. Please stop sharing, Mr. Thank you very much. Dr. Hani, please.
Yeah. Thank you, Dr. Ayman, and thank you for the presentation.
Good evening, sir. This is Suresh from India.
Yeah. Next presentation
Yes,
is
sir.
maze solver using webbots. Yeah.
Yes,
You
sir.
can share now. Yeah.
Sir, can I start the presentation, sir?
Yeah. Please share your presentation.
Sir, is it visible, sir? Good evening to one and all. Myself, Mahesh, giving to the conference to give a presentation of regarding the maze solver robot using V-boards. My faculty Sujata and the other student of the my batchmate is Ruja. The introduction of the maze solver robot is using here. They're using the V-boards, means that is where the robotic simulation software which can use the robot can move from one place to another place, or you can use the V-boards. We can pick and place, and like with the help of these V-boards we can use lot of simulation products with the robotic systems. V-boards is used in simulation software for the robotic system. Introduction. Autonomous robot requires navigate and areas reaching the target point successfully. That means the robot should reach the destination without any without any obstacles, and reaching the dead end locations. We can move the robot automatically with like a human without any human interaction. It can itself solve the problem and move the robot from starting to end position, and also it avoid the trap situations. The robot deal with the scenarios like dead end, like fire existing, like any wall detection. Like we can the robot should come out from the trap situations like that and move forward to the final position. This brings out the maze solver algorithm which can implement simulation of autonomous robot limited and onboard resources. In this we can we can with the help of using cameras and natural environment sensors, we can with the help of the robot move detect the any obstacles, like avoid them. Next. The main object of the project is to make the control based efficiently autonomous. Here autonomous maze solver means automatically the robot should follow the instructions by itself without any human effect. The robot means solve the robot from starting to end point without autonomously without any mobile controlling, like that. The robot should follow that. Here as I also already said, the Weibos is a software instrument which can use the robotics. So we can design we can design the robot will move or pick and place like that. Here we get here the Weibos is the software. We can create the maze like maze, and the epoch means it is one type of robotic software which is inside in the Weibos. Like a controller of robot. Here we using a Python language. With the help of that, we can code with that. The wall following with the help of the maze solver robot means with the mazes have different types of mazes like wall following, line following, and like that. Different. Here we going with wall following. That means the robot should follow the wall, and according to that, the robot will move. Here some of the conditions, like here the robot will start from the starting point move forward. Here we using the left hand route. That means the robot will follow the left hand side wall according to the move. If any dead end is there, that it will turn to right or else left or else straight. That means like if we the point is dead end, it will rotate 180 degrees and move straight up onwards according to the, like here the given conditions. Left wall is present, move forward. Here left wall and right wall also present, like turn right. That means we should rotate. If you know left wall and turn left, front wall is not available, turn left. Like here given conditions to solve the mesh and without any avoidance. Here, as you said, here I said the mesh means here. It means here the mesh is there. This is the wall of the mesh. Okay. Later. The main mode of this mesh solver robot is we can solve the movement of the robot in shortest time. The robot work itself, it's a human interaction. Without any human interaction, the robot will move. This mesh solver robot we can help in various situations like platforms, militaries, and industries. Future scope. It can use it in various operations like pick and place in industries, like without heavy loads, and also in industries there are a lot of routes to avoid them. With the help of this, we can pick and place the robot within the shortest path. According to that, they can place the in position. We can also use this like verify the existing operations, militaries, medical purpose, and we can use this. Conclusion. The path planning algorithm plays important role building a pattern. Here the path planning algorithm is main important. That means the robot should analyze the path and according to the conditions, according to the path, it should solve the mesh and reach the end position without any obstacles and without any collisions. Result. The moving of robot is designed a serious walls. Here, as I said, we can use different types of meshes like wall mesh and line following mesh. At the end of the robot will follow with the help of laser and detect edges of the corners of the wall. According to that, the robot will follow the condition signals and controller drives and rotate the move the according to the straight position of the mesh. Yeah, with the help of the active sensors in the, as you said, the robot is have lot of sensors like camera, like IMU, IR sensor. Like the mesh, the robot will be present in different types of sensors as available in the Weibo software in the robotic system. The project video I will show here. As shown here, the robot will move like left hand route, follow the wall. According to that, they can decisions like here, right, left and right. According to that, they can turn right to right position. Like that, we can see this the wall follow here didn't. It will follow the and turn back into 180 degrees. It can follow the directions. Yeah, like this. Finally, the main task is to complete the task with less time, without any human effect, and we can use anywhere like these situations. And thank you, sir. And thank you for giving this opportunity for conference.
Yeah, thank you so much, Dr. Manish, for the presentation. We now open the discussion. Is there are any questions? Is there any questions for Dr. Manish? Yeah, so thank you so much, Dr. Manish, for the presentation.
Thank you, sir, for giving this opportunity.
We're back again for Professor Dr. Ayman.
هستاذن حضرتك دكتور هاني قدم البحث ده وانا هلحق حضرتك لو سمحت.
Okay, the next presentation, three-phase induction motor drive with back-to-back converter by VF method using Typhon Hill software. Authors Dr. Suresh and Zahira.
Shall I present my screen, sir?
Yeah, I hope yeah, okay. You can now share the presentation.
Yes, sir. My screen is visible, sir?
Yeah, okay. Yes.
Yeah, thank you, sir.
Yes, thank you so much. You can. You have around 10 minutes to 15 minutes for your presentation.
Okay, sir. Thank you. Thank you, sir. Thank you for great opportunities to present our thoughts. So myself is Suresh, and my co-author is Dr. Zahira Madam and Dr. A. Kapil sir. The title is Three-Phase Induction Motor Drive with Back-to-Back Converter by V/F method using Typhon Hill software. So the main objective of the most common electric motor used in industry are three-phase induction motor. So normally we called for TPIM. So they're normally called for TPIM. So here we have the main objective. So the three-phase induction motor closed loop. Yes, sir. So V/F speed control is analyzed. The constant V/F control is the most adaptable. So you have different type of speed control technique for the three-phase induction motor actually. So the number of poles will be changed and the rotor resistance will be adjusted, stator voltage will be adjusted, slip over recovery scheme. In this best method, we have to move on to the V/F control method. So that is a voltage by frequency control. The three-phase induction motor speed control analyzed for 4 different loading conditions. So one is constant load, step load, and sawtooth load and triangular load. So complete this simulated with help of the Typhon Hill software. So this is the overall block diagram for entire work. So we have to connect it for your grid. So this is a grid, then followed by you have to connect it with your converter, AC to DC converter, then followed by connected with your filter, and then DC to AC inverter. Finally, you have to connect it for the motor. So grid to the motor, in between you have to connect to back converter. That is we called for AC, DC, AC converter actually. So here this is a closed loop. So definitely we need for the controller. We have to using the controller is nothing but PI controller we are going to use. We are going to apply the loading conditions. So this is the loading condition applied in the motor. We have 4 different loading conditions. We have to analyze for what is the control technique we are using for V/F control technique. So these are the parameters. So we are going to design for the entire simulation. So the grid frequency is 50 Hertz, carrier frequency 10 kilohertz, and then the stator as well as rotor resistance. Yes, sir.
Your slide is not changing, sir.
Ma'am, now it's sent, ma'am? No, ma'am?
Yeah, your slide, please. Slide is stop. Slide is only in the first one, the first page. The slide don't moving.
Okay. I will stop share and then once again share, sir.
Yeah.
Okay. So now it's okay.
So please.
Now it's okay, sir.
Yeah.
Number 3.
Yeah, first one, first page. Now in the first page, you can move forward.
Yeah, it's in 4th slide, sir.
No, sir.
Please move
Go to slide share.
Yeah.
Yes, sir.
Yeah.
Yes, sir.
Now it's okay, ma'am?
Now it's okay.
Yes, sir.
Okay. Right.
So go to
the
slide share.
slide share போனது மூவ் ஆகும் ஆக்சுவலா. செக் பண்ணி பாக்குறேன் மேடம். மேம் இப்ப பாருங்க 3rd slide இருக்கா? மேம் the 3rd slide, ma'am?
Yes, sir. Continue, sir.
Okay. So this is the simulation parameter. So we have to using for constant V by F method. Is normally we are using for synchronous speed. Is ns equal to 120 F divided by P. So we have to control the corresponding speed itself of the torque. So this is the torque equations. So based on the different the slip ranges, we have to adjusting for the torque. So we are controlling the speed variation. So this is the various frequency level. We have to increasing the frequency level. We have the three stable region, unstable region, normal operating region. So from the stable operation only we have to control. So we have to different frequency values. Automatically have the speed will be adjusted. So this figure is here the three-phase induction motor V by F characteristics. So the x-axis is the frequency, y-axis for the corresponding the voltage as well as torque. Now we have constant torque region as well as the voltage, the constant power region. So we have to analyze with the form only for the stable operating mode. So the red color we indicating for torque, and then the black color is indicating for the voltage profile. Yes. So the PID control normally we are going to use to controlling for the entire process. So here we are going to selecting for your PI. So proportional integral control only we are going to use. The feedback is the motor speed, which is compared for the predetermined speed level. So this is the entire simulation corresponding the closed loop for back-to-back converter for three-phase induction motor with the help of the four different category of the loading conditions. So we have to analyze for the loading pattern, the constant load, triangular load, as well as short tooth load, as well as step load. So this is for the corresponding the constant load. Sorry. This is for the corresponding the constant load. We have to adjusting the voltage is 1 per unit, and then the frequency is 55.75%. So this is stator current as well as the torque almost is constant. As well torque is almost is constant, as well as for speed almost is maintaining for is corresponding 1500 RPM. This is a constant speed. So now we have to triangular loading condition. The triangular loading condition, you have this frequency level is 51.86, but maintaining for the voltage profile is 1 per unit. So the triangle loading condition, you have into the torque is around is 4 Newton meter, and then the torque, the speed also we have to monitoring is less than 1500 RPM. This is 1484. So this is for the corresponding short tooth. The short tooth we have to analyze for the 1 per unit for the voltage, and the frequency is 51.26, the frequency level. And the short tooth, the inverter current as well as the stator current we are going to using for here. The TPM torque as well as the three-phase induction motor, the torque at the short tooth load as well as the speed, the curve will be, we are going to measuring with for the 5 millisecond for the dimensions. And then the last one we are going to using for the corresponding the step load. In the step load, we are going to the frequency level is very high. So the frequency is 52.37, and then the voltage profile is 1. So all the loading conditions, the voltage profile will be 1 per unit, only the changes for the frequency. So we are going to adjusting for your V by F control technique. So we are going to use for the constant load, short tooth load, step load, and triangle load. So this is a waveform the corresponding. This is a waveform for your corresponding the speed. This is the corresponding for your the corresponding the torque. So the final conclusion, the closed loop speed control of three-phase induction motor is discussed under various loading conditions. The 4 loading supplied for TPM. V by F method is used for analysis for the speed control. The speed and torque are monitored and compared for all loading conditions. Finally, the simulation result shows that the constant speed and triangular load, the same speed is achieved with the constant torque. So analyze for the 4 loading conditions, constant load and triangle load is a best one to compare with our V by F control technique. So these are the references. Thank you, sir. So if you have any queries, please, sir.
Thank you very much. Thank you very much for your very interesting presentation. Please, are there any questions? Are there any questions? Please kindly stop screen sharing. Yeah, yes, thank you. Thank you very much. So the next article is called Effect of Model Coupling in Designing OOK Mimo Transmission System over a Measured and Standard Multimode Fiber. Please, Professor Musaddaq from Al-Mustaqbal University College, Iraq. Please kindly start sharing and please kindly start presentation. دكتور مصطفى.
ان شاء الله.
يا اهلا
اوكي دكتور.
بحضرتك. اهلا بحضرتك.
الله يحفظك. الله يحفظك دكتور.
تفضل يا فندم.
Doctor, I will speak in English for this presentation. I will previously show the presentation for the first project, and now I will show only the simulation frameworks because I told you about all the projects and the principle of them.
Yeah,
so
please.
I will share the.
Yeah.
Yes.
Start sharing, please.
Okay.
Please screen share.
Doctor, kindly, can you allow me to not allowed to share? Okay. Kindly, I will show you the simulation frameworks and the run of the all simulations. Regarding the Mimo transmission over multi-mode fiber run, this proposed system shows three channels for OOK, which is on-off keying, shift keying, which is a modulation format with a low cost. Previously, I showed you that I will take advantage for three important parts, which is the low cost, high performance, and less susceptible for noise. This system offered a long transmission Mimo transmission system over multi-mode fiber, which is present a long transmission and even present a transmission for Mimo, which is present a high performance. So when we run the simulation framework, we will see that the results showed many promising results for high transmission rate and long distances, and we can show that there are differences between a measured and standard mode coupling. In Mimo transmission system, we used two parts. The first part, which is because we need more distance, we use the mode coupling. The mode coupling, we will use it in a first transmission system, and the second transmission system will be used without any mode coupling. For the first, we will find that the results showed that the eye diagram for the LP modes tell us that the results is okay, and we can show that without coupling. Also, the eye diagram is very perfectly without coupling, and when we can use the mode coupling, we also get a promising results. Now we can find the radius versus the mode field, which is as we show that the LP modes, the LP0 mode, the 1.1, even the 4.1, we can see that all these results showed a promising result that a transmission system was successfully happened. And the second transmission system to be for a whole transmission system performance, we used a 12-dimension space division multiplexing system. For optical fiber, this is a very high transmission system for bitrate. The bitrate that achieved from this system nearly exceeded 12 terabit per second. We used many techniques for making this happen. We used a solver, we used a multi-mode fiber, a transmission system that used in this system depends on n-dimensional SDM. As we show in the results, we will see that we will get a 12 modes for this work, and we can get a 12 modulation formats constellations. This will tell us that we can get many bit rates in different places. We can use a QPSK, QAM modulation format with a 16, 64, even more levels for QAM, and this will let us get more transmission rates. The transmission performance, as we can see now, the run for the system, our system, the system will achieve electrical spectrum, few mode fiber, which is a kind of multi-mode fiber, which used multi modes, and mode coupling is achieved. Mode coupling means that all modes are sharing the same color, and there are many opticals there, and we solve it by using a Mimo system in the receiver. As you can see, a joint adaptive Mimo processing and joint decoding used to get a better performance for the results. This is a link response, which is electrically present electrical signal, and now we will get until now the program is processing. We will get the final results for our program very soon, which will explain the constellation diagram for the 12-dimension space division multiplexing system. It takes several minutes because our system is nearly complicated, because we used many techniques, so that the running take near 5 minutes. Now the results will be shown on the screen. As you can see, there are many results, shows the dimensions, many dimensions and many polarizations, takes advantage of all of them, will get a very relaxable and very promising system for the optical network. We can see that all the QI shows a successful transmission for all the data. And there are many other systems that designed under our supervision. For the time of the conference, I will explain them later إن شاء الله. شكرا جزيلا دكتور، وتعبناكم ويانا، وإن شاء الله نلتقيكم بالمؤتمرات القادمة. شكرا جزيلا.
شكرا جزيلا دكتور مصدق، وأمتعتنا حضرتك بالنتائج الممتازة، وإحنا إن شاء الله بإذن الله حضرتك تلقي معنا دلوقتي حالا، يعني منتظرين presentation ورا presentation. شكرا جزيلا. I would like to ask, are there any questions?
If there are any questions, it will be welcomed.
Yes, okay, sure.
Okay, thank you very much.
Questions? Okay, so thank you very much. Please stop sharing, and let us move to the next article titled Water Quality Detection Using Cost-Effective Sensors Based on IoT. Please, Dr. Hussein Khadim from College of Engineering, University of Baghdad, Iraq. Please kindly start.
نعم، السلام عليكم ورحمة الله وبركاته.
وعليكم السلام ورحمة الله وبركاته. بعد إذن حضرتك اعمل سكرين شير وتفضل مشكورا.
نعم. شكرا لإدارة المؤتمر. Our presentation, Water Quality Detection Using Cost-Effective Sensor Based on IoT by Hussein Jabbar Kadhim, Faik Kadhim Ubaid, وحيدر محسن رشيد. Introduction. Nowadays, water quality monitoring faces challenge because of global warming, limited water resource, and growing population. Smart solutions for the water quality monitoring are gaining importance with advancement in communication technology. One of the simplest methods in water quality monitoring is the Water Quality Index, which enables to use to detect quality change and trends. This study aims to use the IoT to create a smart and cost-effective system. The water quality sample are monitored using separate sensor connected to the microcontroller to identify water samples whether safe or harmful for drinking use. The work methodology contained the water quality detection device is generally composed of pH, turbidity, temperature, and total dissolved solid sensors, as well as Wi-Fi module to transmit data. The Arduino microcontroller represents the core controller receive any of the 4 input sensor data to display on the LCD. And also the Wi-Fi module establish a link among the hardware, cloud, and mobile application, and also ThinkSpeak platform. On the proposed device, the hardware consists of the 4-parameter monitoring sensor that help to measure real-time value. where the sensor are directly interfered to the Arduino Uno microcontroller, where the sensor parameters are measured by immerse each sensor into the different water sample sources to identify and classify water for drinking use. Flowchart. When the system power on and read the water quality sensor value and calculation of the water quality index with compared with the environmental parameter threshold, and also the box contain the all component of the system. The result and discussion. The result of water quality detection device of the ThinkSpeak platform dashboard used to examine the data collected from the sensor that stored in the cloud for each water sample, where the turbidity value with the NTU unit when figure A and TDS, the total dissolved solid value with P part per million unit in figure P, and also pH value for figure C, and temperature value with the unit degree with figure D, and also finally water quality index calculation with the figure E. The water quality detection device result on mobile application display the data collected for each samples. If the measurement of each sensor is less than the maximum allowable concentration of the selected parameter, then water quality index classified as drinkable water. When the data are higher than the specified maximum allowable concentration, then the water quality index is classified as polluted water. And the result of water quality detection device are tested with 4 groups of different water sample, namely T1, T2, T3, and T4 group, are collected from various water sources, and the parameter compared with the environmental allowable limitation adopted by World Health Organization, such as turbidity for figure A and pH for figure B and TDS for figure C. And finally, the graphical representation of results that can predict the properties of water depend on water quality index calculation, in the cloud. The result of various water sources samples were classified into 3 categories: drinkable water for group sample A, T1, and less pollutant for T1 and T3 samples, and moderate pollutant for T4 group from sample. Conclusion. Despite the existence of several smart water quality detection devices, the study topic remains as challenge, and the design and implementation of the smart and cost-effective sensor for water quality detection device for drinking water quality index are discussion in this work. 4 water samples from various sources are examined, and the findings that determine whether the water is drinkable or not, based on water quality, WHO, and water quality index procedure. Overall, result of this study reveal that quality of the water supply from several sources sample is poor, and the water purification system instead are insufficient. And finally, in the future work, additional sensors should be included in the system to increase the capability and collected data from all water sources sample. Thank you very much, وشكرا على تحت هذا المجال.
شكرا دكتور حسين على هذا العرض الرائع وهذه المعلومات الشيقة. سعدنا بمشاركة حضرتك، ونورت المؤتمر ونورت مصر ونورت الدنيا كلها.
تسلم دكتور، الله يحفظك.
الله يبارك في حضرتك. الله يبارك. هل توجد أسئلة؟ Are there any questions? لا توجد أسئلة. Then we shall move to the next article titled Using Arduino, Create a Management System for Street Lights and a Monitoring System for Objects. Dr. Haura Jassim, Al-Mustaqbal College, Iraq. Please forgive me for misreading names. Kindly forgive me. Please start sharing and kindly proceed with the presentation. So, Dr. Haura Ne'ma Jassim, Al-Mustaqbal College. Are there any authors for the article using Arduino create a management system for street lights and monitoring system for objects?
فاهم هو تقريبا الدكتور مصدق شرح البرزنتيشنز اللي هم خاصه في اول واحده.
طيب يا دكتور، طب تفضل حضرتك.
لا تفضل استاذ.
لا تفضل حضرتك تولى بقى. انا كده الحمد لله قضيت جزء وساعدنا برجوع حضرتك. تفضل يا فندم. تفضل
اتفضل سيادتك. اتفضل اكمل اتفضل.
طيب هعمل بحث وحضرتك بعد كده. طيب ننتقل للبحث التالي اللي هو investigation of solar radiation impact on the surface temperature and performance of photovoltaic panel. الauthors موجودين؟ From Aditya Engineering College, India. Are any authors present for article 2296? Forgive me for not reading the names. I'm just, I will read again the article title and please announce if you are present. Investigation of solar radiation impact on the surface temperature and performance of photovoltaic panel. Any authors are present? Shall I skip and proceed to the next one? Next article title, Healthcare Monitoring System Using Renewable Energy Based Blockchain Enabled IoT.
Wait a minute, Professor, I am sharing my screen.
You will present this article, Healthcare Monitoring.
Yes.
Oh, you're welcome.
I have two articles. I present both. Okay.
Which one? Which two ones?
96 and 97.
Okay. Yeah. Okay. You're welcome. Please forgive me for not being able to read names. Please start sharing and please present your article and your names and your affiliation. And thank you very much for participation. Thank you very much. Please start sharing.
Wait a minute, I'm sharing.
Yeah, okay. Take your time and start screen sharing. Yes, we can see your screen right now.
Yeah.
Please start with the first article.
Yeah. Good afternoon, everyone. Myself, Dr. Durgesh Nandan, and I am presenting this paper on behalf of my team, Dr. Akshay Kumar Tripathi, J. Pavan, and Dr. Mangal Pate Aruna. Basically, that paper title is Investigation of Solar Radiation Impact on Surface Temperature and Performance of Photovoltaic Panel. Basically, in this paper, we discuss about that. What are the impact of various things on PV panel performance? Solar photovoltaic energy conversion emerges as one of the most popular sustainable solutions for generating electrical power through PV panels. PV panels are designed to function in an open environment where the surface is subjected to a wide range of solar radiation. Solar radiation is directly related to PV panel performance. There is a need to understand its impact on operation of solar PV panel. The primary focus of this research is on the effect of solar radiation on the surface temperature and performance of PV panel. Objective of this work to carry out to investigate the surface temperature of the PV panel as a result of impact of solar radiation. To perform this, a field study was conducted under different sunny days, and on every day of study, the panel performing along with its surface temperature was measured. This work basically belongs from Internet of Things, solar energy, and mining that. Basically, like impact of PV panel surface temperature on its performance, the increase in PV panel temperature restricted its operation to minimizing the effect of the panel. The introduction of appropriate cooling help in increasing the lifespan of the panel by avoiding mechanical damage of the panel cell. Experimental setup and methodology. Here you see that there is a measurement setup and instrumentations which we use for that experiment in figure 1, and in figure 2 you can see the laboratory's experimental setup in which we study the impact of lights and other things on PV panels. When we make this arrangement for a study and then we found the various results, the impact of solar radiation on panel surface temperature is measured in the field, and the value of recorded panel surface temperature for 7 different sunny days is tabulated in table 1. Table 1, the variation of solar radiation affects the panel temperature, which may further affect the operation of solar PV panel. Based on the obtained regarding of table 1, a graphical relation between solar radiations and panel temperature is plotted and is shown in red in figure 3, where the horizontal axis represent the amount of solar radiation falling on the panel surface and vertical axis represent the reading of PV panel surface temperatures. Here in first table, you can see the relation between solar radiation and panel temperatures. And in table 2, comparison of PV panel performance between field and laboratory study under constant panel temperature 31 degrees C. This one is the comparison of short circuit current of PV panel between field and laboratory study. That this one is the red one, shows the field, and this one shows the laboratory experiment. That in table 3, percentage reduction in field of performance of PV panel when compared to laboratory study, then you see that there is no much major changes. That if I talk about the IAC, then there is a 2.4, 3.5, 3.42. That's increase only found that, and decrease of BOC is 11, 14, 15, 17. Averagely like up to 11 to 90% we found that. Here we draw the graph between library and field. Comparison of maximum power output of PV panel between field and laboratory studies. That so at the end we concluding that this study confirmed that fact the increased solar radiation increased panel temperature, and due to this a significant reduction in panel performance was reported when it compared with constant surface temperature condition of PV panel. It can be concluded here that when the PV panel exposed in an open environment, then its surface experiences the increase in level of solar radiation that enhances the surface temperature of PV panel. Therefore, the efficiency of a solar PV panel reduces, that makes its operation ineffective. Thus, a proper and frequent cooling system is suggested for efficient utilization of solar panel. These are the references of this paper. Thank you. If anyone has any query regarding this research investigation of solar radiation impact on the surface temperature and performance of photovoltaic panel, kindly ask. I try to answer this. Anyone has any query?
Yes, please. Are there any questions? Are there any questions? So, okay, please, Doctor, proceed to the next article you will present. The next article title is Healthcare Monitoring System Using Renewable Energy Based on Blockchain-Enabled IoT.
السلام عليكم. العفو دكتور.
Give me 1 minute, Professor. I am sharing second one that.
Yeah. Okay. Okay.
My screen is visible?
I have a question here. Please say your question.
عفوا دكتور أنا قبل هاي محاضرة محاضرتي بيبر ما شرحته.
نعم حضرتك
قطع الكهرباء.
نعم أنا وصلتني الرسالة وبإذن الله بعد هذه المحاضرة يأتي عليك الدور مرة أخرى.
أوكي شكرا.
نعم هذا الأستاذ يلقي محاضرتين بعد أن ينتهي حضرتك يأتي عليك الدور بإذن الله. بإذن الله. أهلا بك. أهلا بك. So please now it is time for healthcare monitoring system using renewable energy based blockchain enabled IoT. Please, Doctor, proceed.
Yeah, good afternoon, everyone. And now I am presenting my second work, healthcare monitoring system using renewable energy based blockchain enabled IoT. It's a combinedly performed this work by Dr. Mangal Singh and myself, Dr. Durgesh Nandan. Outline of
please show the slides for the new presentation.
Yeah, I'm. Wait a minute. Yeah, is it visible, Professor?
Yes, now I can see. Yes, please start.
Yes, now. Okay.
Start, yes,
yeah.
Please start.
Okay, basically in this work, entire outline is a introduction and objective and background, system modeling, design of proposed method, result and discussion, and conclusion. Healthcare monitoring is the main issue in rural area, especially in developing countries like India, where a broad urban disparity is having the provision of medical care, but more than half a percentage of total population residing in the rural area. With the increase in technological advancement in the recent scenario, the healthcare sector has also seen a rapid transformation from traditional hospital to distributed patient-centric approaches. Blockchain technology used the cryptography function to ensure the security of data. The person connected to the blockchain network can only access the patient data. Solar energy is a renewable energy source of energy that can help to increase the lifetime of IoT device or wireless sensors node. Objective of this work is to provide a more efficient, reliable, and best healthcare monitoring system to every person living in remote area and saving the cost of treatment. To interface different medical sensors like temperature sensor, pulse meter sensors, etc. with microcontroller and transmit the data to cloud server. To secure the confidential data collected by IoT device by using blockchain technology insist of the cloud platform. To increase the lifetime of IoT devices by using renewable source of energy like a solar energy for generating power supply. To alert patient and doctor in case any medical emergency take place with that. Background of that work has IoT, blockchain technology, and solar energy. This one is our system model that basically we use ECG sensors, inertial sensors, blood pressure sensors, and pulse oximeter sensors that and solar panel, DC to DC converter and battery and microcontroller that, and via that we make one architecture that's a transmitter receiver and alert to patient and doctor if any medical related problem created that. This one is our sensor system models and via this circuit we implement that entire architecture. Basically we use pulse meters, DHT11 and node MCU as a hardware descriptions of our architecture. Methodology is that basically there is a node MCU microcontroller unit and it connected to temperature session, pulse meter session, and power supply that, and via cloud it transmitted that. here, design of our proposed model is like this. This one is our microcontroller, and this one is the various sensors that. And when we connect that body, it monitors health that. So result and discussion, here you see that like when our setup get used that for patient body temperature analysis graph, then it gives the date wise, like it give the temperatures that we tested in various dates and various time frame that. And here when with our same device, we use the patient pulse rate analysis graph that, and we found that it's worked properly, and at the end it fulfilled our objective of research papers. For developing this work, we refer these references that if anyone has any query, you can ask your question. I try to answer that.
Thank you very much for this interesting presentation. So are there any questions regarding this article? Okay, thank you very much. I will get back. Yes. I will get back to the article we missed because of technical difficulty. So now is back to the article, using Arduino, create a management system for street lights and monitoring system for objects, from Al Mustaqbal College, Iraq. Are you ready for the presentation?
Yes.
Yes, okay, please.
Using Arduino, create a management system for street light by and presentation حاورة نعمل جاسم.
أهلا بحضرتك، تفضلي.
In the outline introduction, hardware device and procedure, of the construction of smartization, use energy in the morning, and they have a high installation cost, which is a hard disadvantage for developing our lives. The standard system had only two choices, on or off. According to the accident, those involved pedestrian walker accident are 3 to 6 times more likely in the night time. It's being shown to minimize walker collision by nearly half. Hardware device and procedure for easy of understanding this experiment. It consists from the LD in off time, turn off, and there are nighttime, for the LED or in dim state, as shown in the figure. And this component in the experiment represented by the Arduino Uno. It is the integrated circuit, and the 5 LED and 6 resistors and 5 IR sensor. It is a project represented by if there are objects in the front of the IR sensor, it is light to the object and receive the infrared light and give this signal to the Arduino. And there are also LDR sensor. The photoresistance is increased. This resistance, the 0 is a maximum darkness, and 1023 it is represented maximum. We have the flow chart for the automated street light. We know when there are daytime or nighttime, this gives the data transfer to the Arduino, which is represented the microcontroller, and this microcontroller convert this signal to the discrete value from 0 to 2023. This value then put to the decision if this value under the threshold value, it is represented the nighttime, and the nighttime then also will choose depending to the IR sensor. If the IR sensor having the this light can be in a high voltage, and another decision is put in the dying condition. And also that if the threshold is this value is greater than the threshold value, it is represented the time is daytime, and the street light the off station. Serial, the number of the object can passes from this street. In this figure, we show the structure of the connection of all the components in the experiments. We show the LDR, it is connected to the VCC5 and the ground, and the A0, it is analog pin, and we have the 5IR that it also have VCC and the ground, and it is connected to the analog pin. And the output of the Arduino, it is going to the LD as shown in the figure. The result shown, we have for the result in this picture. In the top, we show that if there are LDR in the night, the daytime, the LEDs is in turn off, and when in the light, if the nighttime, the LEDs is in the dime, and in the down of this picture, we show the when there is the object is passed from the street light, this LED conclusion, the suggested street light automation system is the most cost-effective method of reducing energy usage. It allows to avoid the manual switching for replacing standard LED units with the solar LED units. This technique is a sample.
شكرا جزيلا لحضرتك على هذه المناقشة الشيقة. هل توجد أسئلة؟ هل توجد أسئلة؟ دكتور هاني، نستمتع بإدارة حضرتك. تفضل يا فندم، تفضل نستمتع بإدارة حضرتك.
شكرا جزيلا دكتور أيمن، شكرا لحضرتك. We will move forward to the next presentation. ICEST2022 modified Latch protocol for wireless sensor networks. by Dr. Salma from College of Engineering and Technology, India. Again, we will move to the next presentation, ICEST2022 Modified Latch Protocol for Wireless Sensor Networks. By Professor Dr. Salma. So we will move to the next one, ICEST2316, Design and Optimization of Optical Orthogonal Frequency Division Multiplexing, OFDM, Long Haul Transmission, enabling chromatic dispersion compensation. Yeah, so we shall move to the last one, ICEST2321, Simulation of Multi-Dimensional Coding for Space Division Multiplexing, SDM, Transmission System enabling Joint Adaptive Mimo Processing. I think this is the last one. Is there any authors that does not present his presentation?
أعتقد دكتور مصدق من جامعة المستقبل في العراق قام بعرض كل هذه المقالات.
تمام حضرتك، بالفعل. طيب هو في حد تاني يعني is there is anyone does not present his presentation؟
كله تمام.
كده تمام.
تم الإلقاء جميع المحاضرات بالكامل.
طيب كل الشكر لحضرتك دكتور أيمن، وكل الشكر للمستمعين. نشكركم شكرا جزيلا لحسن الاستماع والإفادة. Thank you for all authors for the presentation and for the talk. Thank you so much. اتفضل استاذنا دكتور ايمن، اتفضل حضرتك ممكن تغلق الجلسه
نشكر حضراتكم جميعا، ونشكر دكتور النوبي، ونشكر إدارة المؤتمر. يوم جميل وممتع، يعني استمتعنا بالأحدث الابتكارات العلمية، وبإذن الله يعني دكتور هاني بإذن الله على صداقة ومعرفة ومودة متصلة بإذن الله.
أنا بتشرفت بحضرتك.
الله يبارك لحضرتك، وشكرا للاستضافة، وعلى اللقاء، وجزاكم الله كل خير.
شكرا لحضرتك. شكرا.
الله يبارك لك. حضرتك بقى اعمل اند للسيشن لان حضرتك الهوست.
تمام حضرتك. Also we thank the authors from India, Mesh Pid. Thank you so much Mesh for the presentation and for being with us today. So we now will close the session. Thank you. We will and we hope see you to the next ICEST 2023. Thank you so much.